Hi guys, this is O-level chemistry, paper 11, November 2020, question 11. Which statement describes ionic bonds? A lattice of ions in a sea of electrons? No, this is a partial description of a metallic bond because they should have said a lattice of positive ions. Then the statement would have been complete. Next, electrostatic attraction between oppositely charged ions. This is the definition of ionic bonds. Next, the sharing of electrons between atoms to gain a noble gas configuration. This is the description of covalent bonding. And transfer of electrons from atom of a non-metal to the atom of a metal. No, a metal will lose electrons and a non-metal will gain that electron. It is not possible for a metal to gain an electron from a non-metal. So this is incorrect. So this makes option B the correct option for this question. Question 12. The diagram shows the covalent bonds in an organic compound. Okay, this is ethane. The total number of electrons in one molecule of this compound is total number of electrons. Okay, so we have carbon. Each carbon has 6 electrons present, so 12. So 12 electrons from carbon. And we have 6 hydrogen present. So in total, we've got 6 electrons from hydrogen. So 12 plus 6 give us 18 electrons in total present in the molecule. So the answer here is 18. And the next statement says the total number of electrons in the bond in one molecule of this compound is dash. The total number of electrons in the bond. Okay, so how many bonds are there? 1, 2, 3, 4, 5, 6. 6 CH bond and 1 CC bond. So in total, there are 7 bonds. So every bond has 2 electrons present. So 7 into 2 gives us 14 electrons. So the value of Y would be 14. Which number correctly complete gaps X and Y? So 18 and 14. This makes option D the correct option for this question. Question 13. Which contains the greatest mass of oxygen? So the greatest mass of oxygen will depend on the moles of oxygen present. So in aluminum nitrate, we've got 9 moles of oxygen present. In potassium sulfate, we've got 4 moles of oxygen present. In sodium nitrate, we've got 3 moles of oxygen present. And in magnesium carbonate, we've got 3 moles of oxygen present. The next step would be to multiply the given moles into the number of oxygen moles that are present. This would give us a value of the moles of oxygen. So the highest value would have the highest mass. So now we have got 0.2. So this would be 0.2 into 9, which would give us 1.8 moles. Next is 4 moles. So this would be 0.3 into 4, giving us a value of 1.2 moles. Next, we've got 3 moles of oxygen. So 0.4 into 3. This also gives us 1.2 moles of oxygen. And the last one, we've got 3 moles of oxygen. So 0.5 into 3 gives us 1.5 moles of oxygen. So the highest value here is 1.8. That means 0.2 moles of aluminum nitrate would contain the greatest mass of oxygen, making option A the correct option for this question. Question 14. Compound X has a composition by mass of 63.6 nitrogen and 36.4 oxygen. What is the empirical formula of X? So let's calculate the empirical formula. We've got nitrogen, we've got oxygen. So the percentage of nitrogen is 63.6 and the percentage of oxygen is 36.4. We divide 63.6 by 14, the AR of nitrogen, and 36.4 by 16, the AR of oxygen. This gives us a value of 4.54 for nitrogen and 2.275 for oxygen. The next step would be to divide these two values obtained by the smallest value, and the smallest value is 2.275. So when we divide both of them by 2.275, we end up with a value of 2 for nitrogen and 1 for oxygen. This molar ratio tells us that the empirical formula of the oxide of nitrogen would be N2O. And this makes option A the correct option for this question. Question 15. The table gives the relative formula mass of four compounds and the mass of each compound present in 1 dm cube of solution. Which solution has the highest concentration in mole per dm cube? So they've made it easy for us. All we have to do is divide the mass given by the relative formula mass, and the greatest value would be the highest concentration present. So for A, we divide 3.65 by 36.5, giving us a value of 0.1 moles. For the second one, we divide 9.8 by 98, again giving us a value of 0.1 moles. Next, we divide 2.8 grams of C by 56. This gives us a value of 0.05 moles. And for the last one, we would divide 6 by 40. This gives us a value of 0.15 moles. So comparing these, the highest value of moles is 0.15. That means the highest concentration would be for NaOH. This makes option D the correct option for this question. Question 16. Which sample contains the most atoms? So, water contains 3 atoms, carbon dioxide contains 3 atoms, methane contains 5 atoms, and hydrogen chloride contains 2 atoms. And we are finding out the moles. The greatest number of moles will be the greatest number of atoms. So, 0.5 moles of water means 0.5 into 3, which will give us a value of 1.5 moles. For the second one, we have got 1 mole of carbon dioxide, so 3 into 1 gives us 3 moles. For the third one, we have got 1 mole of methane, so 5 into 1 gives us 5 moles. And for the last one, 2 moles of hydrogen chloride would mean 2 into 2, which gives us 4 moles. So out of the 4 options, the highest value is 5 moles, making option C the correct option for this question. Question 17. The diagram shows the structures of ethene and propene. Okay. Which statement about equal volumes of ethene gas and propene gas at RTP is correct? They contain equal number of atoms? No. This will only be possible if their moles are equal. If they have equal number of moles, then they would have equal number of atoms. This does not depend on their volume. They give equal volumes of carbon dioxide when burnt completely in oxygen? No. Propene would give a higher amount of carbon dioxide because it has a greater number of carbon atoms present. C. They give equal masses of ethane and propane when reacted with hydrogen? No. Propane will produce a greater mass because it has got a higher MR. And last, they react with equal masses of bromine. Yes, because both of them have a single double bond present. So both of them will react with 1 mole of Br2 aqueous per mole of the compound. That means 1 mole of ethene will react with 1 mole of Br2 aqueous, and 1 mole of propene will react with 1 mole of Br2 aqueous. So this makes option D the correct option for this question. Question 18. Aqueous copper to sulfate is electrolyzed using copper electrodes. The current is constant and the anode is weighed at regular time intervals. Which graph is obtained when the mass of the anode is plotted against time? Okay, anode is where oxidation takes place, and oxidation of the anode means its mass would decrease with time. So this eliminates options B and D, which are showing an increase in mass. A shows a non-uniform decrease in mass with time. C shows a uniform decrease of mass with time. Now, since they said the current is constant, so if the current is constant, that means the amount of copper that would oxidize would also be constant, which means the decrease in mass would be constant. So based on this, option C is the correct option for this question. Question 19. Concentrated aqueous sodium chloride is electrolyzed using inert electrodes. Which row shows what happens in this electrolysis and why it happens? Okay, change occurring. Oxygen is discharged at the anode. Anode is where oxidation occurs. Oxide ions or hydroxide ions will be converted to oxygen by reduction. No, no, no. Oxygen is discharged at the anode. Oxide ions will lose electrons to form oxygen. Hydroxide will also. No, this is correct. This statement is correct. Okay. Explanation. Hydroxide ion loses electrons more easily than chloride ions. No. This is not the explanation for the change occurring. The change occurring here is correct, but the explanation is incorrect. B. During electrolysis, the pH of the electrolyte increases. An increase in pH means that it becomes more basic. And since we have loss of chlorine, hydroxide ions are present and sodium ions are present because we have loss of hydrogen. So hydrogen and chlorine are given off in the electrolysis of aqueous sodium chloride, and sodium and hydroxide ions remain, which result in the formation of NaOH, and NaOH being basic will result in an increase in pH. So this change is correct. Explanation: the electrolysis in aqueous solution involves the discharge of H positive ions as hydrogen gas. Yes, this is correct. So the explanation is also correct. Next, solid sodium is discharged at the cathode. Sodium is never discharged. This is wrong. The products stay the same if the aqueous sodium chloride is replaced by molten sodium chloride. It cannot, because molten sodium chloride will have only sodium ions and chloride ions. So in that case, we will have sodium discharging at the cathode and chloride discharging at the anode. So this is also incorrect. So as a result, option B is the correct option for this question. Question 20. The energy profile diagram for both the catalyzed and uncatalyzed reactions between nitrogen and hydrogen in the Haber process is shown. Okay. What is the activation energy for the formation of ammonia in the presence of a catalyst? Okay. The purpose of a catalyst is to lower the activation energy requirement. Both A and C represent activation energy, but the activation energy represented by A is larger, meaning this is for the uncatalyzed reaction. Whereas the one shown by C is for the catalyzed reaction. Now B represents the loss of energy when the reaction occurs. That means it is delta H. And D is basically going from products till the transition state, which is the maximum energy value during the progress of a reaction. So B and D are incorrect. A becomes incorrect because it is for the uncatalyzed reaction. This leaves us with option C as the correct option for this question.